welcome back to another episode of BetterTech. My name is Peggy Tsai, one of your BetterTech hosts. I'm pleased to be here today to talk about the future trends, the evolution of Tinyml and embedded systems. I'm joined here today by Prateek Tripathi, the founder and CEO of a company for Tinyml. Prateek, can you provide a brief overview of your background and journey in the field of Tinyml and sensor learning?
Thank you, Peggy, for having me here. To start off with, my journey began in the field of circuits and systems. By trade, I began as an IC designer, where I used to design small chips. That's always been intriguing to me, how these smaller devices have taken over the world, where you're using them for communications, you're using them for recording this podcast, and you're using it for all sorts of things. Over my journey, I started getting attracted towards the field of bioelectronics, and that required me to learn a lot about sensors. And what that brought me towards was this lovely field of sensor learning and Tinyml. In simple words, Tinyml is machine learning that is really small, but really efficient. And what it can help you do is do really specialized tasks like classification, recognition of your voice when you say, okay, Google, hello, Siri, right? All these tasks. And sensor learning is something that works very well with Tinyml because we want our sensors to help us integrate with our environment, our devices. And so what that allows us to do is create sensors that are better at understanding its own environment and its own sort of imperfections and using Tinyml to give us better sensor results. And that's how I started this company known as AirML. And what it is trying to do is go into industries and fit itself into the industrial machineries and sense better for this new and upcoming field of Tinyml in Industry 4.0. Yeah.
That's really interesting, Prateek. And I know that many in the audience are probably wearing a Fitbit watch, or they use a lot of IoT, Internet of Things today in their day-to-day life. But I think what's fascinating about what you're talking about is specifically in the manufacturing industry. So can you elaborate more specifically in the mission and goals? How did you decide to select the high-value manufacturing industry as the application for your sensor learning?
So federated learning is something that's become popular in a way that when you get a model that is trained for your devices, let's say for your Fitbit or even for your mobile phone, these models are generally trained. But over a period of time, when you start using them, these models learn on the go at the edge itself sometimes, and they become better at recognizing your voice, let's say, or recognizing your heart patterns if you're measuring your heartbeat from time to time. And the best thing about this is when you're training these models specifically for a particular task, these tasks, when they learn better at the edge, they also keep data privacy into account. And our industries are really worried about their data. To keep a factory floor on the cloud is the next big dream, but to send all that data all the time, it raises huge data privacy constraints for this high-value manufacturing sector, who could be held hostage by cyber criminals. And thus, this field brings something new, where you can have AI enter this industry in a safe manner, and while at the same time, the industry can also reap the benefits of AI within the industry floor.
Absolutely, Prateek. And certainly, it's just not manufacturing that is concerned about data privacy. Every industry has those same concerns about their data being in a cloud, a public cloud, even private clouds. There's potential security and privacy issues. So you mentioned it in your last response, but can you talk a little bit more about how artificial intelligence will play a role in these embedded systems? And also, interestingly enough, what challenges you faced with artificial intelligence in building your startup company?
So AI is going to play a huge role when it comes to embedded systems, because it's one thing to train the model, it's another thing to use it. And these embedded systems are the things that interact at the edge with the rest of the systems that we have built around the world. And so embedded systems, as they continue to become more and more powerful, as we make better and better chips, we might even go one step deeper from embedded systems to simple ICs that might be running their own local neural network models as well. And The biggest challenge is how do we train these big models and still condense them, quantize them, make them smaller, and maintain that accuracy? Because as you start to quantize things, as you start to take some leeway with your model, you prune your model in certain manner, you would lose certain aspects of it, and you might lose certain accuracies of the model. And so this is a big challenge when you try to create something like this. But if the task is highly specialized that you're training for, if you're not training for something like a general AI model, right, like that's becoming more and more popular these days, it's much simpler because you know what is the task that you're looking for. You know what you want your model to do, and so in that manner, it's easy for embedded systems to be trained in a manner that they can do specialized tasks through TinyML.
And I've heard that, especially when a lot of the talk today is about large language models, it sounds like what you're referring to are more small language models, specific domains that will specifically help you solve your problems. So I think let's just take a step back. I think many in the audience are, again, not familiar with TinyML. That is a new terminology, at least for myself as well. So how has this field evolved in the coming last years, and how is it going to evolve in the future? Can you talk a little bit more about what's going to come out of the future of TinyML?
So largely, because my PhD is also in the field of TinyML, largely applications will be suitable for healthcare as well, which is going to be heavily dependent on something like TinyML. To understand, we can put up a case scenario, a simple case scenario. Let's say COVID-19, which we all faced very heavily. We needed to send all our sort of tests to labs, certified labs for doing PCRs. Everyone's now well aware in the audience for PCR. Now, during my PhD with my professors, I've been working on sort of sensors that can do this sort of test in the palm of your hands using the integrated systems, right? And this is a huge opportunity because, let's say, for future pandemics, if this technology takes fruition using the power of sensor learning and TinyML, you'd be able to classify with the precision of PCR model in at your home, whether you're suffering from what level of infection and how whether you're infected or not. It's huge opportunities when it comes to TinyML because again, medical data largely private. We care a lot about it, and as when we hear something like something going wrong with our medical data, it really gets us worried. And so in those case scenarios, TinyML is going to be a boon for the world. Something similar comes from the field of Industry 4.0 as well, as we mentioned earlier, because if you want to bring AI onto the factory floor, you will need data and you will need to train that data. But it's very difficult for companies that create equipments that are used in sensitive technologies like aerospace, even your automotives, to trust that their data will be in safe hands. So they would love to have ownership of that data. And something like TinyML and sensor learning can allow them to have ownership of that data while still using AI for their benefits. Yeah.
Wow, that's really interesting. And before I continue, really congratulations, Prateek, on presenting at the TinyML EMEA Innovation Forum 2023. That must have been really exciting. Could you share with the audience some of the key takeaways from your presentation?
Yeah, thank you. So I think the key takeaway from the presentation was that TinyML has two factors to it. One is the embedded systems that is going to come quickly into the market. But the other factor, which will come, but it will take some time, is ASICs, which are application-specific integrated circuits, very small. And I think what it helps us do is it creates specific sensors using the power of ASICs that we can use for detecting better something in the field of biomedical. So in this case, at India, I actually presented my PhD from one end to the other, where I actually showed them a journey that you do not need to just stick to the concepts of TinyML on embedded systems, but you can actually do it at the circuit level. So you can create circuits that can also learn by mimicking the way our neurons learn in our brain. So that's a field of neuromorphic electronics, and it's been up and coming, and it's going to be a new fact for TinyML. It's going to be a new phase of TinyML with those type of circuits because they are analog signal processing circuits and they work in the analog domain. They don't work in sort of the traditional digital domain that we are used to. And what that allows us to do is really create very low power systems And I think that's one of the key takeaways from that talk. If it's available on YouTube, feel free to go through it and learn a little bit more about this field. Yeah.
Oh, absolutely. So can you talk a little bit about what the benefits of having this analog? So apparently low power, meaning potentially in areas where there's a lack of source electricity, that can be very powerful. Can you dive a little bit deeper? I think that's potentially game changing for many countries.
Yeah. So I think it's if we look at sort of AI, it's all about GPUs, big, powerful, power-hungry GPUs. But again, when it comes to specific tasks, you really do not need that much compute power. And so if we are looking at specific applications, analog signal processing, which is our world, right? Our world is completely analog. We need to convert that world into digital for our computers to understand. And what we are doing through sensor learning is we are pushing all the processing towards the analog domain as much as we can, and using a sort of really low powered circuits, which can do a lot. Analog can do a lot. It's just that people are not as much aware, and plus it takes a lot more to design. It's not just a science; it's also an art. They say analog electronics, and so analog is going to be like analog signal processing is going to be amazing for countries that are constrained by power, because they're really cheap. If you can make all these things into chips, these chips are really, really cheap to sell once you start sort of mass producing them. And that would be a huge benefit for sort of the entire world, because you would be able to push this quickly across the world the way you've pushed mobile phones in the past decade.
Fascinating. And I'm sure there's going to be a lot to watch out for in this field. But just going back to manufacturing, since that is the main focus of your company's Airs ML, can you talk about some additional challenges and opportunities in integrating artificial intelligence? Because that really is the future, I think, for manufacturing industries today.
So I think the manufacturing industry is very fascinated by AI, but very, very cautious as well, because it's two things. And these are traditional sort of industries that have kept their equipment safe for quite some time, in the terms that the things that they make are used in our day-to-day lives, and something like that needs to be something that enters that factory needs to be trusted and needs to be vetted completely. And that's the reason that it's taking long for AI to enter factories, and it's not as fast as it could have been, especially when it comes to things like sensor data. It really makes sense that these industries jump towards Tinyml, but they fear it as well, because they do not really understand how this model is going to communicate with the rest of their infrastructure, whether it's going to fit in. They still use really old systems. The machines have been running for a long time. They do a lot of preventive maintenance. Sort of, they try to stay ahead of the problem. Sometimes that leads to sort of over maintenance, whereas sometimes it leads to under maintenance. And something like this, which sits sort of at the edge, that is looking at their machine, looking after their machines all the time, is going to be really beneficial to the industry. And I think one huge sort of challenge is to convince them, because it's a mindset, right? If things are going the way they are, you become really comfortable, and it makes it difficult for new technologies to enter into the field. And so it's also a huge task to sort of convince everyone that, hey, this is sort of the right way forward, because it's the future. It's definitely coming. It's just who gets on board, how fast.
Absolutely. The change management mentality and embracing innovation is seen in many industries. But Prateek, maybe for the audience, if they could actually hear a specific use case of how you've been working with a manufacturing company, and specifically what you've done to install these sensors and the benefits they got, I think people really appreciate the work and the company that you built.
Yeah, so we currently just are in the moment of finishing a pilot project. It was our first pilot project. It was funded by Innovate UK. So we basically were running it with the High Value Manufacturing Catapult in the UK. It is called the MTC. They are basically sort of the playground for developing new tech like these. What we were doing was we were looking after a robotic arm for them. That robotic arm was doing a particular chore all the time. And our aim was to sort of recognize if there was any abnormality in the way it was functioning. So what we did was we collected a lot of data in its normal working condition, because these are expensive machines. You cannot make them fail just to create a classification model saying that, hey, the machine's failed. And so we are mainly looking at anomaly detection, where what we are doing is we're training on a lot of good data, and we are setting thresholds. And what that's allowing us to do is it's allowing us to figure out when the machine is deviating from the expected behavior. And so that's a very sort of specific use case that we're looking at for the robotic arm. It's also interesting if people like mathematics to understand that you can always transform signals. It doesn't always have to be in the time domain. And so we're also not just looking at these signals in the time domain, we're converting them into spectrograms, and we're looking at them in sort of other different transformation domains as well. Markov transition fields. It's fascinating how sort of developments from different fields can be combined together, and you can sort of create something new out of this. And if the bigger challenge for us is to now take this use case and spread it across the industry, get the word out, and get into a real factory floor.
Really, really fascinating, Prateek. But to put it in even more simple terms, a lot of your sensors is really monitoring the machinery for malfunction, for breakage, because it's often difficult and challenging, and depending on where the machines are located, difficult to identify where issues happen. So you really need to have that live data, right? Is that exactly what the data is? It's the performance of the machines?
It's actually live data. And one of the main reasons for me for getting into sort of this was I learned about this quite a while ago. And so in 2018, Cisco released a report, right? 1 quintillion bytes of data was being produced by IoT devices every day. And less than 1% of this data was ever being analyzed at all. It was just being stored or kept, or I don't know, we were just losing that information. And so it really makes sense that these models that can sit at the edge, they can actually act like a sieve for us. They can look at that data, they can keep the data that makes sense, and they can get rid of the data that is just not useful. It's a challenge to get this sort of a model out there which is continuously going to look at your data all the time, because it will require the industries to install these new sensors, and that's where sort of our major challenge will be once we start getting traction in this sort of a thing, where we'll have to sort of quickly scale up and try to spread to as many factories as fast as possible. And we'll have to also modify our models depending on the machines that we're looking out for. And so transfer learning will play a huge role between factories. The one good thing is we'll own the learnings from these factories, we'll own the models, and so these models can quickly be sort of refined for other factories as well. And that's sort of the way we're going to try to scale it. But yeah, in simple terms, it's a caretaker for your machines. It's going to be sort of cradling it, looking at it for all the time, trying to take care of it, and trying to sort of reduce the traffic or reduce the amount of data that you really need to store on your cloud platforms as well.
Terrific, Prateek. And it's really thanks to the Innovation Forum for supporting startups, for supporting students, graduate students, PhD students like yourself, to have this opportunity to put these POCs to life. And so Prateek, what advice would you really give to other students, early professionals who are looking to enter the field of Tinyml, sensor learning, or any AI-driven startup?
I think the most important thing is to stay current. So you really need to read a lot, and every day there are so many publications coming out. People are making huge movement forward, and so I think you need to read a lot of papers if you've already entered the field. But if you're looking to enter the field, a good starting point is maybe just sit with a simple Arduino if you want to enter into the field of Tinyml. So Arduino has designed a Tinyml kit. It's $50, so really not that expensive, and it allows you to do a bunch of things like design your own keyword spotting. So what you can do is basically you can train it on your voice, and you can try to help it detect your keywords, the things that you're saying. So let's say you say Peggy, and you can make the microcontroller generate certain signals, and you say Prateek, and it generates certain other signals. I think that's a very sort of cool hobbyist sort of way to enter into the field. It'll keep you interested. You can connect a relay to your microcontroller. You can connect lights in your room probably. It's a super simple and easy way to enter the field of Tinyml. So I would encourage that if people want to start, they actually start by getting their hands dirty in this field. Yeah.
Very interesting. And I
Yeah.
think that would make a perfect gift for my 12-year-old son to
Yeah,
get him
definitely. Yeah.
interested. And so definitely a lot of opportunities. And as you said, a lot of reading and writing just to be current in this field. So, Prateek, we're closing up to the end of our podcast and really want to just close it up by asking you if there's anything else you would like to share with our audience about your work, any upcoming projects, or just the future of AI in your area.
Yeah, so I think the most important thing is if you've not heard of SML, please do follow us on LinkedIn and do check out our website as well. What I would like to say to the people is that I think TinyML is a really up and coming field. And if you are looking, if you're a new student who's entered into the field of EEE, or if you have just started your computer science courses, I would really encourage you to sort of look into this field, and maybe you find your passion here as well, just like I did. And yeah, I think thank you so much, Peggy, for organizing this. It really gave me a platform to talk to your audience and sort of give them a little hint of a small field, a tiny field actually, that is up and coming in the field of AI. So yeah, thank you.
No, thank you, Prateek, really for sharing your story on how to be an up and coming and successful startup. Certainly with Tinyml, there's a big ML for you in the future. So encourage everyone in the audience to check out AIR's ML on the website, as Prateek mentioned, and learn more about this fascinating and certainly growing field. So thank you again.